But with the new technique, it hardens so fast that much more complex objects are possible. In order to show you what we can do with that, this is the sort of patterns that we can generate with this new technology. And these are all made in one go. And you can see the consistency of our material that makes this pattern deviation really pleasing. So this was a very simple triangular column. And basically every so often you ask the robot to go out 1 centimeter or so. And this one actually does that twice, and then it lays a single layer again, and then repeats the pattern offset a little bit. So it's relatively simple to make in 3D modeling. And if you have a constant supply of material like this, it's really easy to manufacture as well. So you can see the column. This one we made on a Friday afternoon for fun because we wanted to make a column, see what that would look like. This stands over 2 meters tall, and the print time was just about an hour. So in relation to what Amy was explaining about plastic printing, one of the key advantages here is just the speed at which we're able to make large objects. So within approximately an hour, we're able to make this column. And our design philosophy now is what we're good at as a startup is to avoid problems of, for example, the laws we have to adhere to in terms of construction, which obviously don't exist in concrete printing yet. So what we do is we print the formwork, and then we insert rebar and we pour traditional concrete, which calms the nerves of the constructors that have to be involved in these projects, because they can use the mathematics of the existing concrete to calculate what strength these beams have to hold. And we are actually just printing the formwork. In the near future, the compressive strength of our concrete, which is relatively very high because the cement content is very high, can be used as well in the calculations. But for now, we avoid the problem by basically printing the formwork, which has the added benefit of being sustainable in the sense that we don't have to use traditional formwork anymore. And there's a lot of waste in formwork right now. So we avoid that point by making custom objects that are optimized in terms of form and aesthetically very, very pleasing. So that's our focus inside the concrete printing industry as well. You have the large scale printing of buildings, for example, and then you have the more architectural design type applications. That's what we're focusing on now, because I think that it is making the best use of robots and additive manufacturing and the advantages of form freedom. So here are some more examples of just simple patterns that we can generate with the same parametric design. Here's a project we're doing with the European Space Agency and the Technical University of Delft, where we are printing objects for on Mars. And this pattern is similar to the wall design I showed you earlier. It's called the Voronoi pattern that optimizes for shape, but also optimizes for heat transfer. And when I first started the project with the European Space Agency for going to Mars, and TU Delft, I thought, I don't want to go to Mars because it's very far away in my mind. But immediately we had lessons learned of this heat distribution that we can do by form optimization. And we immediately had clients already asking to print electrical boxes for them outside, incorporating this heat distribution techniques for the railway system in the Netherlands. So there's a good cross learning in these type of projects for sure. I'll leave you with a final show of just the sort of aesthetic detail we can reach. This is a simple pot or bar stool or wall garden element printed in approximately 30 minutes. And you can see a beautiful pattern emerging just from this parametric design. So to reiterate, what we do is we sell complete hardware systems in concrete printing, including the software, which we sell also. We do printing as a service and provide consultancy in the business as it is now. If there are any questions, please don't hesitate to email me or ask them right now on the session. Thank you very much.
Thank you very much, Walker. Very aesthetic presentation, very beautiful pictures. I'm quite impressive, the type of printing you can do. So very, very, very interesting. There is maybe a question from Thomas or not. I can see a raised hand, but do we have a a question from the audience. If not, you mentioned that there is a lot of startup or companies in 3D printing for concrete objects. Or I remember only cases like you show us that aesthetic application or aesthetic parts. Do you think there will be a market for construction or more solid construction? I will say, I don't know how to
Yeah, I
express
understand the
it.
question.
Yeah.
So no, absolutely. There are already a lot of projects that are in this area. So especially for the automation in the construction industry, having constructive elements is required. I mean, that's really the target, right? So there are already firms doing very large scale printing for constructive elements such as housing. The reason we don't focus on that is because if we have to be competitive with companies that have, 5,000 employees and big teams of constructors and giant budgets for material, you don't win in any sense whatsoever. And we like to make our mistakes early on small. So we've seen many of our mistakes made by competitors also, but while printing buildings, and the failure costs are just high when you're printing objects that are that size. What we see now is a very large interest in machines worldwide. So people are definitely interested in the technology, but just as in plastic printing 20 years ago, engineers and constructors and architects still have to be familiar with the potential of the technology in order for them to adopt and find the business cases. So is it constructive? Absolutely. Are there business cases? Absolutely. But we still need to discover them, and the market needs to start discovering them from their side.
Thank you. There is a question from Matteo.
Hello. Hi.
Hi.
Hi. I have a question. I would like to ask you if you think that prefabrication in construction or construction on site is better for your technology, according to your presentation and what you showed. What do you think is best?
Good question. So a key question in concrete printing right now, it's the big juxtaposition between on-site or off-site printing. And the standard answer and the correct answer, I think, is that off-site printing right now gives you the possibility of controlling more environmental variables. So we print off-site because we are still discovering, for example, what humidity settings. Here in the hall we have, we're a startup in a hall, we have a lot of space, but we have no climate control. So we had a heat wave last week, and that changes our parameters. And we've printed in freezing cold as well, and that changes our parameters again. So we're still learning what humidity is required, what sort of temperatures are required, right? Yeah. High five. Let's have a call, and we can both cry about how hard it is to control these things.
We're not that far. So.
But important is, though, what's interesting, and we've printed here in 5 degrees Celsius, we've printed here in 35 degrees Celsius. So when clients ask us what is sort of the range you can print in, indoors, when you have a reasonably controlled environment, the range of what we can do successfully is actually very large, right? So we can print in quite a large range of temperatures and humidities. Nevertheless, one of the things we're doing now is building in a lot of monitoring in order to predict sort of how our print is going to act. So I recommend printing indoors because there are still things to discover. I applaud the companies with the larger budgets that are trying outdoor printing. I would like to learn from them, but also let them discover these things outside.
Okay.
Thank you.
Thanks.
There is a question from Stefan Saver. I don't see the name. Saver, okay.
Hi, how's it going?
Hey.
Volker, thanks for the talk. It's really interesting to hear a lot about the concrete printing process. I actually work in the AEC industry for a company working on large-scale commercial projects globally. I'm an architect myself, and I find, of course, this really interesting. Question I had for you was, it sort of piggybacks on the last question. It seems like for a long time, concrete printing has been, at least in the AEC industry, has been limited to precast elements, right? So as you just mentioned, being able to control a lot of the parameters of printing, humidity, temperature, all of that within a lab somewhere. How do you anticipate, or if you do, how do you anticipate that changing for large scale projects? I know you're working on smaller scale projects at the moment. Do you and how do you anticipate that might change for large scale architecture, architectural design when it comes to precast first, cast in place? As you said, the big question is really how do you solve getting the robots and to a site and printing them or using them to print on site, with all of the climate issues and site issues. But how do you anticipate that?
So like underneath your question is basically the question, is 3D printing of houses going to be viable, yes or no, right? That's one of the big questions that get asked. We get so much media hype on 4,000 euro houses, which I'm telling you now is not possible. Houses printed within 24 hours, that's also, quite difficult. So to have to remove some illusions there, right now, all these things that are printed outside are still being printed under tents. So first, a giant construction is built, which is basically making the on-site construction an off-site construction temporarily in order to control the environment. That's not a criticism of how they're doing it now. It's just that, as we said, they're discovering the same problems. Is it viable to print houses? I'm not a proponent. Many in the industry are. I think the material costs are very high. And I don't know enough about construction or prices of houses to know how much are you actually saving in labor costs. What I do like when I hear other companies that are doing this, such as the large scale printers, they say there are design change, so blunder cost reductions, which I think is a good argument. There is speed increase in terms of throughput, which I think is a good argument. So they're definitely similar to any other 3D printing process. There are advantages to be had. So I think it will remain a part of, or it will become part of the construction printing portfolio, owing to this lead time decrease and owing to the cost of blunder reduction, that decrease, but not necessarily for labor reduction. That I'm not convinced of. So will we see robotics in construction in the near future? Yes, we will, because that is where the increase in added value per worker is really needed, right? We're lagging behind incredibly in the construction industry. So they will be out there, but maybe not for printing houses, but maybe for more in larger crane type settings for entire apartment blocks or multiple axes sort of gantries that do both concrete and other things, lifting or wood, or, we're going there. But for now, these pilot projects are still struggling to control the outside conditions. So slowly but surely, I would say.
That's great. And maybe a very quick secondary question to this is, you mentioned right now you get. Are we out of time? If we're out of time,
no, go ahead.
Yes, we are going to show the break. So
okay, it's a super
okay.
quick
Okay, you
second question.
Go ahead.
It was really just related to, you mentioned right now you guys are printing formwork, and that's kind of the way to get around, from a code perspective and logistically how contractors like to work in this method. How do you anticipate that changing? Printing formwork as opposed to printing the actual form. Do you see a transition?
So for the same arguments that I had earlier, is that from what I see from just a practical point of view, when you print formwork, one of the disadvantages of 3D concrete printing is the cost of the material, right? The cement content is high, and some additives have to be put into the concrete in order to make it suitable. So the price will remain high compared to traditional concrete. Why? Because we've been using traditional concrete forever, and it's extremely cheap. So I don't see purely on a price basis 3D concrete printing material winning out on pouring. Secondly, pouring is also very fast, right? Because you can pump at a large volume, you can use a high aggregate size, and you can even pour around rebar. So again, you're avoiding a lot of the problems that we have with 3D concrete printing by not being able to add, for example, rebar, right? And then the costing. So I think a combination of both 3D concrete printing for formwork, which saves you the traditional formwork like wood, which is a bigger saving than many people think right now. And then combining with traditional techniques is the way to go, because at some point you're having the best of both worlds, right? Where you're doing form optimization, you're doing speed of printing and digital manufacturing, and you're using the economies of scale with the extremely low price of the materials such as concrete that are out there now. So you want to use advantages of both sides, in my opinion, instead of throwing everything we've learned about concrete overboard and starting all over again. That doesn't make sense to me.
Thank you.
Very interesting. It's 10 to 5 here, but I think it's 10 to 6. Do we have time for last question? I'm asking to the organization. Maybe we can just don't do the stop break. I don't know if needed, because I think there is a question from Sebastian also. So, all right. Sebastian, do you have a question? Or? I'm not sure. There is a question.
I have a question. Could it be possible, Olivier?
It depends on you. I propose to do not do the break, and so because we have 10 minutes. Right?
Yeah, perhaps we'll go for. But it's a quick question. It's about in some situations perhaps cement is quite brittle. How about use of reinforcements? And how could you deal with the automation and for the reinforcements?
Mm-hmm.
You are working on that?
It's a good question. So as I said earlier, one of the ways we deal with reinforcement is to avoid the problem altogether. So there are a few strategies you can do. First of all, you can print a formwork, as we explained, and insert traditional rebar later, and then pour concrete. You can also design by using compressive properties only, so build under compression. That way, again, avoiding the formwork. There are obviously people doing research now into how we can insert this rebar into the 3D concrete printing system. But as you know, by doing layer on layer, it's very difficult to combine. I think it plays to what I said as well on combining the best of both worlds. There are now construction startups, several, they're getting good funding for automating rebar production. But they are automating a section of traditional construction, which is rebar. And the volumes in that section, the money to be had is for optimizing traditional rebar construction. So we're optimizing formwork and concrete, and they're optimizing automation or automating, formwork construction with rebar. And at some point, when they are more mature, these automations, they will meet again. So, then we will use the advantage of concrete printing and of automated rebar construction. I don't think in the near future, we're going to discover some way in which to insert steel into the printing while it's happening, just because physically it's very, restrictive. But this automation is happening on different fields, and they will come together at some point. As I said, the question was asked, how do you see that in the future? That's how I see that working, that once these automations have been more mature in the industry as such, then we will combine them.
Thank you very much for your vision.
So there is a last question in the chat from Ricardo Viola. It's regarding the size of the printing part. Is there any consideration to have in account regarding the width of the position because of the weight of the part?
It's a good question. Different techniques will have different width of bead. The big advantage of concrete printing as opposed to plastic printing is that the width is not as sensitive. So we can print things that are 5 and 6 millimeters wide, and we can print things that are 45 millimeters wide. And I know of research that does 800 millimeters wide. So the width is not as sensitive as in plastic. So it depends on what do you want to make. One of the advantages of having a thicker bead is the stability of the part. So you want to have it stand up while you go, right? And even if it hardens immediately, if we're doing angles of 45 degrees on very thin things, they will collapse. just by the pure weight of what you're trying to hang in the air. And also what's possible is that they will crack. So there's shrinkage in concrete. And if you have very thin objects, you start, seeing this cracking fractures as well. So that, speaking to how brittle the material is again, the height is the same. So we can do a 4 millimeter height. We can also do 20. And we're now doing variable layer heights where we're going from 4 to 20 millimeters, just based on, the speed of how we can move the robot. One consideration to have there as well is that concrete, when stacked, is actually very monolithic. So in concrete printing, if you saw through a concrete printed element, you cannot see the layers. You cannot identify where they are. Even though you can see them on the outside, you will not be able to identify them on the inside. So there's a lot of research going on there too about under what conditions this holds. And even printing something, letting it dry and then printing over the top, you'd think that it deteriorates the connection between the layers, and surely it does, but not as significantly as you would have imagined. So there's quite some research on that as well. Under what conditions can we reprint over things? So it's a bit longer answer than what you asked, but these all hang together, in your consideration of bead size.
Okay, thanks a lot. Definitely, you are the first to have a lot of questions today, so it's
Slow
very
start.
fascinating debate. So maybe I propose to go ahead with the presentation without a break, if it's okay. So it's the turn of Alban Mallet. Thank you very much.
Hello, everyone.
Hello, Alban. I will do just a brief introduction and I give you the floor. So Alban, you are the CEO and co-founder of X3. So you are architect graduated from École Nationale Supérieure d'Architecture of Paris. You lead the research and development at X3 to develop a new large-scale 3D printing system and printable materials. So I think it's probably the same way that Volker. So
yeah, thank you very much, and thank you also Volker, because I think you are one also of the 3D printing in the industry which has the same vision as us. So I think that was really interesting, and I will follow the direction and continue with also what you said. So that's going to be nice. I'm going to show you my screen. Just wait for a second. Slideshow. Okay. And if I share screen, is it okay?
Yes.
Okay, thank you. So just to start, I always like to start with our vision, because at some point it's really important to share what we think about 3D printing. So our idea here is to shape a desirable low carbon built environment. And I think that's something we need to think every day, because if we start to look at 3D printing, sometimes you can just go another path. So that's what we really try to stay on our vision. Just wanted to remind what the problem in the construction and what we want to resolve is productivity, quantity of waste, and the time of the project, which are always bigger than what was expected. And I think that's where 3D printing is interesting. So our answer with 3D printing is to lower the material consumption, to do lighter structure, so you can have faster construction at lower cost, and tailor-made design. So that's the bullet points that we want to focus on, and we think that can achieve and can resolve some problem of the construction. What's our vision and our mission at X3 to have 3D printing available all over the world. And that's where we stand. I'm going to just explain in a few words what's our model, economic model, and how we imagine to go in the market. So what we have done is name PaaS, printing as a service, because we think we are not here to just sell printers, but we are more here to help constructor and precaster to have this new tool, to know how to use it, to know what they can do with it. So that's how we build up our solution. Our solution is quite in fact, simple, I would say. So it's a fully automatic 3D printing process from mixing to printing. So everything is automatized. It's because it's been like more than 5 years we are working on it. So we start with really simple tools, and now we build up and build up and build up. And why we push it is because we are the first user of our technology. So we prefer to have it as simple as possible and as automatized, because we don't like to work hard, and we prefer that when it's a machinery working better than human. So we have developed a multi-component 3D printing system where we change the rheology online at the nozzle. It's been like 5 years we are doing this, so we have quite a knowledge on this, so that's quite interesting. We're also doing what we name mono-component 3D printing, but the difference has been well explained before, so we'll not explain more. We also are looking at multi-material 3D printing. Today, our main material is concrete, but we are also printing plaster, and we are printing clay. We also make the solution evolve to have a faster setting and to be sure that the solution will be able to go on the market and will not be like hours of print of clay, for example, or for plaster. So we have, with the same machinery, we can manage to print clay, plaster, or concrete. So that's quite interesting, because we think we need to put the right material at the right place. And the idea is not to put concrete everywhere, but for example, I always saw those houses where they put the entire wall in concrete, and for us that makes no sense, because you don't need to have strong, large concrete just for separation. And plaster would be much more good value, or clay could be really good value also for separation. And we also developed multi-robot collaboration, because we are really focusing on automatization and pushing the results and to have different level of development. So this is our basic system. So we're mixing concrete, cement with sand, with additives. So we do a mix which is not setting really fast. That makes us able to manage to control if there is environment change, or if you want to stop the print, continue again. So you can manage to have like more than 3 hours before it starts to set. And we put some additives directly inside the nozzle, where we control really well how it gets mixed and really fast. And everything is managed with digital models. So we are working on software and on hardware at different levels, because we want to go from design to production with a continuous flow of value and production. So that's our system based on a manipulator, which is a robot. We are using ABB robots since lots of years, but we also have developed the solution over KUKA robot, and we could go over other type of robots. There is no problem for us to go on gantries, but we feel like when you go down to the price and do accuracy, 6-axis robots are quite great for this kind of things. And everything is plugged onto the robot, so the feed system and the head nozzle system. I'm going to just show you a video. I don't know if it's lagging or not, but I feel like the best way to present our technology is from some partners' videos. So, because I explained, we are not a 3D printing company, we are giving some services, and we give the technology to some partners, some constructor on Precast. So that's Kurabo. We just installed the technology in Japan, and they have used it in now 5 months or something. And so we make them learn how to use it, and now we are helping them to target the market, target the new types of design, etc. But we need people like Precast or constructor to use this technology to put it in the market, and we are here to help to do that. I will continue. Just to explain a little bit about the technology, I was really interested about the presentation also of, I don't remember the name, I'm sorry, the last presentation on the plastic development, because we feel like data monitoring is one of the main concerns and main things we need to focus on. they've been like more than 3 years. We are really pushing on acquisition of data. And for us, it's really important to be able to collect this data, to analyze what's happening, and also to understand and to correct if there is some default. So that will help us to have always good quality, and also to reassure when you need to go for certification of your pieces and to ensure the strength of your pieces, you will have to show the data. And you will have, when you product you will have digital twin, but with all the characteristics. And we are pushing even more than what it used to be in the construction, because directly you will have a cartography of your piece where you have all the value. We also look at the real displacement of the geometry of the robot. So for the digital twin, that's quite helpful. It's not what we have sent, but it's what the robot have realized exactly. And also we have developed some tools for simulation of the geometry, because when we start, we were trained from failure learning. So we learn, we print, we learn, we print. But at some extent now we are at a level where we are selling our solution to construction industry, and they don't want to make some try and fail learning. They want to have some tools. So because we have lots of work in research here, we are pushing on analysis the characteristic of the material to see if the model is going to stand or if it's going to fall. And we are pushing, it's not just simulating the acquisition, but it's more about the shape with the acquisition of performance to understand if it's going to fall or not. So that's where we stand now for simulation in geometry. So our model today for our business model market, and that's where I think it's really interesting for construction, is to say that we are not just going to sell printers, because if you just sell printers, it will be the same issue that everybody was concerned of. Okay, we will all have our desktop 3D printer at home, and we will print our PCs at home, and we will repair all of our houses with those little 3D printing plastic printers. It's the same problem in construction. If you just sell printers, nobody is going to know how to use it, which type of model to do exactly, etc., etc. So what we do a platform where we are going to help all our precasters which have our technology to have the right model, to know how to print, to have the new constructive systems, to help them also to print well, because we have all the data, so we can analyze and we can push their productivity. So we are more like a tool, but not just a tool. We are here to help to construct the market with them. And we will combine also our architect with designer, with civil engineer and constructor, and together we are going to make good solution. And I think that's where, when we are talking about digital construction, that's where it stands. It stands when you connect all those typical experts in each domain to work together to have a good result, and not just say, okay, we're going to print the whole house in 3D printing, because that makes no sense. We need to push to have the good result. I'm going to show you some projects we have done since a lot of years, and new projects, just to you to see the broader view of what's possible to do with 3D printing in construction. So that was one of our first projects, was maybe 4 years ago or something. What we have done is print a formwork, as what it was explained before. Why? Because it's the simplest way to go for certification inside the construction industry, because you make your calculation not on the formwork resistance, but just in the concrete which is poured inside the formwork. That's really interesting because it's fast, because you don't have to go for regulation, you are in the model. So that was 4 years ago. But what we feel like is like, okay, that's just a start, but we need to certify the whole structure. We need to certify each gram of concrete which is used, because if you remember, our aim is to go as low as possible in carbon footprint. So that's why we need to go and certify each gram of concrete which is used of cement, because we want to lower the footprint of our construction. So that's what we have done with Villa Print with Reims. It's a project with Plurial Novalia. And we have made an ATEX, so it's a certification in France, where we have pushed to define all the all the value of the concrete when it's print, to be sure when we are going to print, if we are in the good range, we can certify the 3D printing concrete. So here, as you see, half of the house is 3D printed, the one in gray, and the one in white is prefab. And that's why, because we think that you don't need to put 3D printing concrete everywhere in the house, because at some point it makes no sense. It could be more expensive when it comes back to standard elements. So half of the house are standard elements, so prefab with really cheap expense. And the other half has been designed to adapt and to connect, for example, with the windows, for good insulation, with electricity, etc., etc. And we have worked in France like during 2 years for those certification, because we want to push the certification all over the world and to ensure that what we are printing is part of the resistance in the house, is not for just some design or extra. So it has been printed, the 5 hours has been printed in over 20 days for all the walls. And after they install it, it has been maybe in 2 or 3 days, they have installed and put all the elements together. So it's like a Lego. And why we managed to have the certification for this one as fast as we could, because it's normal. It's like you have a brick wall. So those are considered as brick. And we have pour concrete inside the one. You see some rebars. So there is some pockets with rebars where we pour concrete. So this is like a maçonnerie chaînée. I'm sorry, but I don't know if the translation in English, but it's like bricks and pouring concrete. And that's where we have the certification. As you can see also with the technology, we are really focusing on having good quality printing, because we think nobody is going to go for 3D printing house if they are ugly. So we need to push for good quality control and do not accept any kind of something not beautiful. That's also a whole project, but it was quite interesting just to see the broad view of what 3D printing can do. So this is Stormwater Collector. So it's not for design. It's really useful because it can be adapted to the site. So we have opened the site. We have scanned where we need to put the entrance and the exit. And we have sent it to the printer. We print it and we ship it on site to have it installed. So it was really fast. And you can reduce the main labor, because normally they are working under the floor. They need to block the road. So it's really complex. And now we can go really faster. It's not, maybe it's not cheaper, but it's faster, it's safer. And because you are not blocking the road, that will not have problem with the authorities and with the people around. Excavation mask, so just to show. Also, artificial reefs are something quite interesting. We have done for a long time. We have done a lot of them. And it's quite interesting how you can see topological optimization is quite interesting, not just for human, but for fishes. And what is great here is because you don't have any regulation about the strength of what you are doing, because it's underwater. So we managed to play a lot with how to adapt the shape to the needs of the fishes, but that could be to the needs of the structure, to the needs of the topology, to the needs of humans. It could be anything. So it's a good example, and it's working quite well. We have a lot of colonization. So we are working with different companies like Ibus, CETEC, civil marine engineering companies. And we manage also to go for large production, because that's also a tricky thing, is to print just one object is not really complex, but when you start to print for mass production, that's where you need to tackle the repeatability of your process, the productivity, and to look at the numbers at the end of the project, say, okay, are we good enough in productivity, so the price is good. So that's why we try to tackle, is to go from R&D research to construction and productivity for construction. I'm going to just show you some video. That was quite a long time ago, because all the floor is clean, everything is clean. Now it's not look like the same, because when you work with concrete, you make a lot of mess when you have a problem. But yeah, you can have nice videos of how it's done, what it looks like. And as I say also, we are not doing just artificial reefs here. We combine artificial reefs with anchor for the boats. So you have an anchor which floats on the top. So boats don't need to put some anchors in the water because it's in a protected area and we don't want to destroy the floor, marine floor. Sorry, the music. And so we managed to adapt this. So fishes start to recolonize really fast. Concrete is great because algae can go inside the concrete and really grow on the concrete, and you have lots of fishing after fish. Three last projects I'm going to pass, sorry. This is one of the big pillars we have done is 12-meter high, yeah, something like that. And what we have done is 6 elements of 2 meters, and we assemble them, and after we put pre-stressed elements. So we put cable inside, we pre-stress them, and that makes us able to have resistance against seismic, paraseismic elements with the wind, with the charge, etc. And that's something we need to combine. And we always think 3D printing is not going to resolve everything. We need to combine high solution like pre-stress elements with 3D printing, and that's where you grow new solutions for construction. I'm going to show you just a little video here. So it's one of our partner Artifact, and as you see, we are never doing like project by ourselves. We always need to go and create the ecosystem between civil engineer, constructor, architect, and we are here to combine all those guys together and to make them work on one type of element and to think of the best type of elements they can make. So that's the installation for the prototype to test it, and after to try to pre-stress those elements to see how strong they can go. So that's one of the videos. I go just for furniture, but really fast to see the quality we can achieve. And with the same machinery, we can do furniture for fine things and also a bridge or a post for structure. I'm going to show you, this is a project we are doing with Roche-Beaubois. And as you see, this is the print, and the quality of the print is really fine, really, really great. And when you are working on this type of quality, you know that it's going to be easy to make a bridge or to make something else because they are really regarding each type of default. You can't have any default on this type of table. And just to show you, we have worked with them to do something we are going to push is to do easy design, easy catalog of design, what you can manage online to change. So you will put your numbers if you want 5 meter, 4 meter, where you need to put your anchor, etc. So this is for table, but you can imagine for house, you can imagine for bridge, you can imagine for anything. And after what we receive from their side is like just some numbers. We put the numbers in the machine and the machine is going to print. So today we are printing all the elements of the table and the furniture are different. And it's not complex for us to do different elements because it's a robot and it's fully automatized. This is the last project I want to talk about. It's a 40-meter long bridge where we're gonna have the certification over the concrete. So the concrete is going to be the one which is making the resistance of the bridge. We are not going to do anything else, and we're going to pre-stress the concrete with cable inside. So those are going to be different elements. So print vertically, which we will have print here or at partner facility. And after they will assemble on site all the elements, put a cable, push it, and you will have enough strength to have the resistance of the bridge. I have a little 3D print model here. So this is how it looks like inside the model. So it's fully hollow. And we are starting also to do the life cycle analysis because as I said in the first slide, our goal is to reduce the footprint of the construction. And we are starting the life cycle analysis and we have really, really nice results. About how CO2 emission we're gonna resolve and have less CO2 emission, but also workers, the difficulty of the workers, the quality of the bridge because it's making prefab, and I think the last presentation explained well also, why we focus in prefab is because we need to have good quality, good security, control all the environment, control all the data, and also it's much more efficient because, for example, today we were printing tables. Last week we were printing walls for houses. The week before we were printing elements for outside. So every day we are printing different things, and it's really simple to assemble if you think really well of the assemble. Also, we are working on material, as I said, and this is the new material we have developed. So it's always big components, but we start to have aggregate, and aggregate with lower our footprint emission because we put less cement with aggregate, and we have the same strength with or without. So because we managed to have the good granularity, and we are working with the partner team on this project. We're also working with Fresine, we are working with Quadric. So always it's a combination of partners because we are working on the ecosystem, and every part of the construction, every people in the construction need to do this part. We are here to connect them and to make them think about how we can build tomorrow. So, thank you very much for your listening, and if you have some questions, we'll be more than happy to answer them.
Oh, thank you, Alba. Very extensive presentation, very interesting presentation. So, do you have some question from the audience for Alba? Yes, Matteo, you have a question?
Yes. Hi. Hi, Alban. I have a question about the again about the joints. How do you deal with two parts when they join together? So before you showed some pictures of parts that they have joints, and often you see that these joints they look in a sort of misalignment. So how do you deal in the construction industry when you say, well, it's about delivering quality, etc.? Like how, yeah, also here in this
These joints, you're talking about these joints?
Yeah.
Yeah, in fact, when we speak about construction in houses, you must be aware that we need joints of dilatation. You can't have a fully print house with no joint. You will need to have joints. And so what we have done here with the architect and the civil engineer is to think about how it's connected. In fact, you can't see it here, but some of the connection are connection maybe like this, or we have different type of connection I can show you, but we think maybe I can show you something here. Can we see? No, we can't. Sorry, because there is the background, but just yeah, we are thinking about the join, and if you think well the join, it's okay. In fact, it's not a problem. Most of the time also you need to know that it's better not to hide them. It's better to assume that there is a join, but that's more about aesthetic and architecture. But it was print how it was designed. So architect wanting to see the join to just explain more about the structure, how it's working. So we put the join, but in fact, the join is just a connection between the two prints. One is going over the other one and go inside. I
agree. But if you look behind you, you have a joint in the image, and the one looks really good because it looks really straight and precise. So that's something that architects, they do care, I think, about joints in construction. So it's
so because you say that the joints are not beautiful here. Well, yeah, really it's something we need to push. Maybe they are not clean enough. Maybe that's something we need to push. I think we are at the start of also assuming some aspects of the 3D printing. Something, if someone don't want join, it's really simple to put some coating on it, just to hide it. But at some point, I prefer not to hide. I prefer to show what's the real structure, how it works, how they are connected to each other. And I think that's the best way to do it. But after, it's more about discussion with architects, etc.
Clear.
Okay, thank you. Do we have another question? We have time because Alban was quite fast, so we have time for questions.
I was going to say it was too long, so it's okay.
No, it's okay. In some of the example you shown us, there was some rebarb inside. Maybe it is this one, yes. So it was after the 3D printing, you put inside the rebarb, or it was printed around the rebarb?
It was put after, so it was in the design. We have left the space to put the rebar inside directly in the design. We have done other projects where we have some spaces we printed around spaces where we connect after the rebar. What you have to, so there is two solutions, and I think the last presentation was quite clear about it, but the rebars, if you have rebars, you will need to pour concrete. That's something, it is like this. If you have rebars, you need to have straight holes. If you have straight holes, you can put them after. It's not a problem. If you start to have rebars curved, maybe that you will need to print around the curved rebars. But at some point, there is not a lot of design which needs to have curved rebars. So it's not really a huge deal to put rebars. What we are working on, but I think we will need maybe 1 year or a little bit more, it's reinforcing the 3D printing concrete. So we have done some stuff. We have like Q and Oven have done, but it's kind of different. With having steel fiber inside the concrete in the length of the layer. So you have the layer going on and you have steel fiber inside, but we are not doing one layer. We are doing multiple layers inside. So something like 10, 20 fiber, long fiber inside. And we are also working on having other fiber in the other direction. But that's something we need to push. And even when we manage to do this, you will understand we will have to certify it. And that will be something also really hard. When you imagine that today we spend 2 years to certify for the concrete just as bricks, when you start to think that we will need to certify for concrete with reinforcement directly inside the print during the printing and the reinforcement, that will be something else. But we are working on it because, as I said, we want to be sure that if we can have just concrete, the shell of concrete, that will be really, really interesting.
Okay, thank you. Maybe another question from
That's what
the audience.
I wanted to show for a connection as an example.
Okay. Okay, so if we have not more questions, I propose to close your turn, your presentation. Thank you a lot, Alba. It was very, very interesting. And we can go with the next speaker. Next speaker is Ricardo Carmo from 3D Construction Printing Technology. Ricardo, are you there?
Yes, I'm here.
Okay, I can see you. Sorry, I will do a brief introduction. So, Ricardo, you are an engineer of University of Southern Denmark in robotics. Your main subjects are robotics, computer vision, embedded system, artificial intelligence, if I'm not wrong. You are working for Cobod International in Copenhagen. And Cobot is the world-leading designer and manufacturer of 3D construction printing technology. We strive towards full automation of the construction industry by designing 3D construction printers and automated processes for building sites. I let you so now begin with your presentation.
Yes, now you should be able to see my screen.
Yes.
First of all, good afternoon or good morning or good evening, depending on whether you're seeing us from. Also, a big thanks to the Center for Rapid and Sustainable Product Development in Portugal for inviting me to give this little presentation during the International Manufacturing Forum series. And also thank you, Olivier, for the intro. And probably I should start going on. So my name is Ricardo Carmo. As you've said it, I'm here on behalf of Cobot International. We're based in Copenhagen, Denmark, and we do 3D construction printers. I'm going to be talking a little bit about the technology. If you need to get to me afterwards for some reason, or if you have any questions that I haven't addressed here in the end, my email is rc@cobot.com. So what I'm going to talk about is, first of all, what is it that we do and how do we do so? And then I'm going to go a little bit about into our history. Where did we start our journey along the way? And I'm going to talk also about our partners and our customers and the projects that both they have done and that we have done in Cobot ourselves. I'm also going to talk about the Bot 2, which is our printer, and perhaps give you a little bit of a glimpse into the future more towards the end. What is it that we do? So we make 3D printers for buildings. Here you can see one of them. At the time, it was the largest construction printer in the world. It was sent off to the Middle East. It's roughly 12 meters wide, about 27 long, if I'm not mistaken, and about 10 height. So it's a pretty big monster, this one. And you can see that we basically have 3 axes. The one where the robot is, where the nozzle is running now. And there's also, that's the X. We have the Y for the length, and then we have the height up and down. This one is pretty big. You can compare it to the van. And obviously we have smaller ones as well, but this was just to give you an overview of what it looks like. Let's see. This is the printer in action. It's actually printing the first building that was ever printed, 3D printed in Europe. This is a rebuild of such building 2 years later. On this, you can see the same printer, only you can also see the hose that's feeding concrete into the nozzle. You can also see a whole lot of people because this print was actually done by students. So they were doing all sorts of measurements and learning everything about that they could. The printer actually only needs a team of 2 to run it. One person controlling the printer itself, and the second one would be taking care of the material, making sure it doesn't run out of concrete. You can see the end of it, and this is what it looks from the top. It's actually 20 tons of material in under 30 hours. So it's quite a lot of concrete as well. What is it that people or us print? Well, it can go pretty much from anything. So on the top left, we have this prototype building that we made first. On the lower left, it's a school in Malawi that it was just inaugurated either 2 weeks ago or last week by 14 trees. And on the right side, you can see actual livable house in Germany. It's gonna be inaugurated still within this month. And these are all real printed buildings. Okay, now to how is it that we do it? There are basically two ways to go at it. Either you have a robotic arm 3D printer in which you have a nozzle attached as a tool, and you still have obviously the hose where the mixture is coming through, or you have also a gantry type system. This is our sort of printer where we have the 3 axes that I've mentioned before, and the nozzle just runs on that. Here, I'd say that if you want to go for more fine printing, then it's more common to have what you have on the left. I think Emil talked that about in the plastics, and Volker also. If you want something that's more aesthetically pleasing or something that you want a little bit more detail, then you can probably get better off with the robotic arm 3D printer. But if you want to make something that's quite big, then a gantry type 3D printer is probably a best option for that job. Also on this right side, we don't have the problem of inverse kinematics. We also don't really need so much path planning. Of course, we need a conversion from the building information modeling to a sort of a set of instructions that the printer can run, but that's about it. Where did we start? So the white building that I've seen a couple of times, that's called the Pod, and it was actually the first 3D printed building in Europe. On the lower pictures, both left and right, you can see that the walls look a little different. So on the left side, it didn't have the flaps while printing, while on the right side it did. So the surface finish is different, even though it's often that our customers don't really use the flaps because they like to see the 3D printing aspect. And I think this actually turned out to be a selling point rather than a problematic issue. I've been to this building. I think it's actually quite nice. It has a small bathroom, a functional kitchen, and it can just work as an office. We did it at the time for 2 reasons. So first of all, proof of concept, so that we know we could actually have a 3D printed building that was actually approved according to safety standards. And the second one is that we have this form freedom. You can see the walls are very S-shaped with a lot of counter turns, and that's not at all easily makeable through traditional methods. We've also done quite a lot of more first 3D prints. So again, this was 2017, this little building called the Pod. It was the first in Europe. In 2019, they made the first 3D printed 2-story building. This is in Belgium. It was done by Camp C. Still in 2019, we've done a couple of different things. So the first 3D printed villa, that was in the United Arab Emirates. And we have also made a first 3D printed windmill tower base. This is a partnership that we have with General Electrics and also with Lafarge. It's a long-term one, and I'll show a few more pictures after that and talk a little bit more about it. In 2020, Perry in Germany, they did the first 3D printed 3-story building in Europe using our printer. And they also did the first 3D printed residential building in Germany. Still in 2020, I've shown a picture of this, the school that they printed in Malawi, but 14 trees, they also did the first 3D printed buildings there for housing, actually. In India, they did the first 3D printed 2-story building, L&T, which is the biggest construction company in India. And guys from Printed Farms in Florida, they did the first 3D printed building. And they're actually now holding a workshop on 3D construction printing. Okay, here I think you can see a little more visually what is it that I was talking about? So you can see the two-story building in Belgium, Camp C. This was entirely made on site with the BA2 printer. Again, this was a proof of concept, and it's just a normal house, only it was 3D printed. We've sent off the printer to the Middle East. That this one is the one you saw in the video. It was the largest construction printer in the world, and not anymore. We have a bigger one now. The 3D printed villa in the United Arab Emirates. The guys that made this villa in Dubai, if I'm not mistaken, they were the same that made Burj Khalifa, the giant tower with about a kilometer height. Okay, now to the Windmill Tower Pedestal that you can see on the left side. So this is the project we have with General Electrics and Lafarge Holcim. And the idea is that they print this basis for the windmills, and then on top of it, they stack the windmill tower itself. And the thing is that at around 100 meters high, the wind is much better to be harvested for energy production. And so they want something that can obviously withstand the windmill on top of it, but they also want to be able to reach quite high in there. You can see in the middle the building that Perry did. This passed all the German standards for construction, and it's actually habitable, so people can move in. As I said, it's gonna be open soon and within this month, I believe. And now we get to 14 trees, and here we come to a point that I'll discuss a little bit more about it later, is that the houses that are printed this way are much more sustainable. For instance, in this ones, there was 70% less carbon dioxide emitted in the making process. And besides that, in Africa, it's not, and in quite a few more places in the world, it's not that they have the same infrastructure. So it's often not easy to move cement around or to just have access to cranes, and neither of that. So once you install things, it's much easier to just print on site. To L&T, so the largest construction company in India, they printed the two-story house, and they used a locally sourced real concrete mix. So again, something that was done in place. The same with the printed farms. They built this, I think it was meant for storage. And in Florida, as you might know, there are a lot of hurricanes, and the building had to actually withstand very harsh conditions, and that was not a problem. And lastly, we also have Precast Customers. So this is something we didn't really anticipate in the beginning, but we've actually got this one. Perry sold it to Rosa in Germany, and we've also sold another for Precast. So people are actually making concrete prints and then shipping them off with our printer, which is rather a little bit of a different market. I'd say. I think that the Alban from X3E, he talked a little bit about this, so that they made their prints and then they ship them off. But it seems that they're also making big prints and not only roughly medium-sized. Our partners, as you might have noticed, are scattered pretty much all over the world. So States, a little bit in Africa. We have 4 printers in Germany, Middle East, and also in Asia. And the idea is that 3D printing is getting everywhere. And I think also something that's, I'd say, interesting is the fact that you don't see the 3D printers going only to developed countries. You see them going regardless of that and for numerous projects. So it's not like it's rich countries are buying it. It's a little bit of everything. Okay, now to the printer itself. So this is only the second generation printer. The first would be the one that printed that tiny white building called the bod. It's very reliable and it's durable, and it actually is the best-selling construction printer so far. And I think there's a few points on why it is successful. So the first is that it's modular. So you can have a printer that's rather small, let's say 5 meters by 5 meters by 2 or 3 height. We have a couple like at DTU, the Danish Technical University. They have a one that's sort of small, and then you can have a giant printer as Perry if you want to make a 3-story building house. Of course, it all comes down to your needs. We also have tangential control with the usage of flaps, and that allows us to have smooth walls. So the idea is that if we're printing in a certain direction, the nozzle is actually following the direction of the wall itself. And then the flaps are just running on the sides and are making the surfaces feel much smoother. But again, as I've said a little earlier, I'd say about 50% of the customers, they don't use the flaps because it's a selling point that people can actually see it's 3D printed. So you can see it on the right picture there. Perry just left it as a 3D print outside, and that's how they went with it. Another point is that we can print pretty fast, up to 1 meter per second, which is rather fast on a monster this size, and especially when you have such a big printer. At some point, we actually tried to go this fast and the pump couldn't keep up. So then we had to go with our suppliers and try to develop a new pump that could actually work as fast as it should to supply the printer with material. We use open source material feeding options. And then again, I'd say this is also something that's nice to have. So people can either make their own magic mixture and then print with it, or they can just go for dry mix mortar and also print with that. And obviously it's certified to be outside. I'll come to this also once again, because there's something I want to talk about. Okay, so as I've said, there are a number of sizes. You can have a small one, you can have medium, you can have large, and you can have larger just by adding a few modules. Right now we have a few limitations, so we cannot go beyond 15 meters wide, but we can go infinite on the Y. So you can basically print an infinite road of houses, and that's not a problem. And we also have a limitation of 10 meters on the height, but we are working on expanding both the height and the height always. That's always a goal. Now to the system itself. So I've been talking about this printer and is it too complex? How much stuff is there in it? How many hidden components there are? It's actually not so complex. So the printer itself, it has 3 sets of modules, one for each of the axes. You can see on the lower picture, there's one module of each, and there's also the nozzle in it and the hose that's feeding concrete mix into the nozzle. Then you need obviously a controller. So this is something that is gonna be running the encoders and making that the step motors actually go where they should be. And then we have a slicer. The slicer is this magic little program that transforms the building information modeling from architects and engineers into something that's actually able to control the printer. In our case, this is G code. So it's exactly the same let's call it language that the normal 3D printers you have in your office and that are printing small figurines or prototype, it's exactly the same thing. We also have some that I think it's quite nice, is a set of cameras. So the person controlling the printer can actually be having a beer in a bar and actually looking at the live feed. And now to the material. So as I've said, people can use dry mix mortar or their own custom concrete mixes. And once you have something that's in sort of the right range of fluidity, I'm not sure this is the word, so that's actually printable. You just have to have some sort of pump it up to the nozzle, and then it goes printing on. We've been discussing quite a lot of benefits from having construction printers, either by using robots or by using these gantry type 3D printers. And I think there are a few key points. So automation that comes together with speed. There's a less need for scarce skilled workforce, which is obviously costly. Labor is costly, especially in the Nordic countries here. And also automation allows for repeatability, which people, no matter how good they are, they cannot repeat the same exact thing twice. Obviously less accidents, but then we go to speed, which always comes associated with the fact that we're using automation. Then there's form freedom. So there's a lot of new solutions that are possible. Before, making an S-shaped wall was something that was not so easy, or making something that looked like the reef coral prints that Alvin just mentioned. That's something that you cannot do so easy with precast. And with this form freedom, you can draw all sorts of architectural stunts that you couldn't before. And then we come to sustainability, which is a topic on its own. First of all, there's less waste. So now you only need to print wherever you need. You don't need to cut the elements so that they fit the design. There's also often not so much need for reinforcement material. So in precast, first of all, you need to transport the precast, and then we have talked about having rebar on and all that. If we are printing, in this case of the GE tower, we have a sort of rebar that's a ring, and it's just placed every few layers. But on the normal prints of houses, the only thing we have is wall binders. So there's no rebar coming up while we're printing. There's the wall binders, and that's it. Also, topology, you can actually have the same area with less material. So again, we go to this form freedom, and you can see by having something that's curved on this lower part rather than something that's just straight, we can get the same areas using less materials. And then we go to new materials. So the idea is that, okay, we're printing with concrete. Concrete has very good properties for construction, but we can actually use other things in it. So for the bod building, that first white one that you saw, it was actually almost a quarter made of recycled roof tiles. And this opens a lot more new possibilities. Of course, the material has to be printable, but apart from that, it shouldn't be so much of a problem. About the future. So speed is always an issue, and again, we're always striving to make better. On the bod building, so the one that was made in 2017, it was reprinted later. It was the video that I said it was made in the beginning, and there were a lot of students in it. And just for the fact that we did it again 2 years later, we did it 20 times faster. And that's a pretty big leap. Also on this right side, you can see the printing of a house, and it took 3.5 hours after we got the drawings till the moment that we printed the first meter of building. And again, here you can see that there's just, you cannot see the wall binders, but the things that go into this is basically giant staples that are binding this outer structure of the walls. Again, for the GE tower, we also did this exact same print, in this case a year later, and we 3D printed 175 tons of concrete with 8 tons of reinforcement in 3 days and 4 hours. And I mean, I want you to take a second and see that 175 tons of concrete, and that was done in 3 days, and that, I think that's pretty fast. And also GE's renewable energy CTO, she talked about the fact that we have this windmill tower basis, and hopefully that we can make use of more of such innovation, using 3D concrete printers to harvest more renewable energy than what we're doing now, because obviously what we're doing now, it's not so capable, I'd say. Now for the BOD 3, so in cooperation with the academia, the same as we have added until now, the BOD was also printed with a printer that had been made in close cooperation with the academia. We're developing the BOD 3, and this next one will have tracks. So again, we have this infinite length that you can print. We'll have multifunctional tools and or a construction robot in it. We're still analyzing which is going to be, or are they going to be both of them, and the printing of different materials, not just concrete. And this we are able to do now already. And I think, again, I've mentioned that this opens a lot more different possibilities. I'd say that, as Volker mentioned, you can have concrete mix, and then you add an accelerant, and you can just make it solid right away. And if you want more fine detail, that's actually good. Or you can have something that's more, let's call it slimy, and you just let it to harden afterwards. And I think that's pretty much about it on my side. This is us. We are about 60. I joined the company exactly a month ago. And shall you need anything or you want to know something about us, you just email info@cobalt.com or me, rc@cobalt.com, and then I'll get back to you and hopefully answer everything that you'd like to know. And that's it. Now I'll take any questions. Thank you for taking the time to listen.
Thank you very much, Ricardo. It's very, very interesting presentation. I'm not specialized in concrete printing, so I think for me it's quite impressive. Do we have
Thank you.
questions from the audience?
I have.
Yes.
Go ahead, Arthur.
No. Thank you for your very interesting presentation about the cobalt technology. You mentioned the precast approach, and also before it was mentioned the precast approach, but also for these big printers, I imagine that is to print on site or in situ.
Yes.
So thinking about I'm not really a specialist also in the concrete or cement or the construction, but there are, I think, a discussion between the footprint or between the both approaches, because there are a lot of people, I think, in this area in construction that are more focused in the precast and prefabrication, and then build on site, thinking that or claiming that have a less footprint. And by other side, I don't know, but perhaps also the other approach is build on site with materials that came from the local. What do you think about the both approaches, and what are your opinion about the footprint of each one, thinking about the sustainability?
Yeah, of course, I'll answer that and I think it's actually a good point. So if you're making something precast, it has exactly the same material, plus it has to have the joining, as Alban mentioned. So if you have something that's precast, then you have to join all the pieces together, and you still have the exact same material, right? And you have the fact that you need to transport it, and you also need to transport all the reinforcement material that is obviously inside that. If you are printing on site, then you basically need to transport only the material there, right? And then you feed the printer and it's all printed in situ, as you said. I'm not sure this answers all of it, or if there's anything you'd like me to touch.
Yes, it's a possible answer. I was thinking about that, because when we print on site, we need to put also there all the material, and off-site also we need to transport all the material, but with more added value because it's already transformed. It's really I'm thinking I'm not sure what could be better, but it's an interesting or an important question to be answered. But thank you very much for your
perhaps I can go like that. So L&T, the largest construction printer in the largest construction company in India, the building that they've done, it's all with locally sourced concrete mix. So they didn't have to buy it from another continent or another country. No, it was all from there. We actually also have, I've talked about the recycled roof tiles. So 1/4 of the material was actually recycled material. And we actually have an option that we want to explore, is that maybe use a pre-existing building that has been demolished and then just take that material and use it to reprint the new building. And that's, I think it's a big point for sustainability, because then you're not generating new material just to make a new print. You're actually re-existing something that's there already, and you just use it for a new purpose.
Thank you.
I have a question also. You mentioned that you can use specific materials, local materials, and my question is how you can manage to print with a good quality, with using materials, local materials, because usually in additive manufacturing, the material is a big impact on the parameters of the printer and the process itself. So I can manage to understand that you can print with different materials, but probably you have to change the parameter of the printer. How do you manage that? Because you sell the printer to local industry. How do you transfer the knowledge to be able for them to print the part of the house with the good quality, depending on the material?
Yeah, I think that's also a good point. I'm gonna try and do my best to answer that, even though I'm not a concrete expert, as you've pointed out.
Ricardo,
But yes,
may I jump in to help you out?
Yes, of course.
Sorry to interrupt. My name is Vitalis. I am also from Cobot, so I will assist Ricardo in some questions.
Good.
In essence, that is our approach, that we want our customers not to source materials from somewhere else and have it locally, because in essence, this is what makes sense in terms of cost, right? Because
Yes.
let's say if I have 100 houses, I won't source materials for 100 houses from somewhere else. This is actually a challenge because in essence, not a lot of countries have the possibility, let's say, to already know and to have experience with what is this 3D printable concrete. And for that, we provide services and also are able to suggest what chemicals can be used, what, let's say, additives can be used, what kind of mixing should be done, and so on, based on our experience on other projects and what we got in terms of feedback from the large customer base we have. And this allows our team to travel to our customers and test local materials with, let's say, our additives are finding these solutions. So we are cooperating, let's say we enter into partnerships with local material providers and the customers themselves to develop something locally. So this is, of course, a process for, let's say, each climate or each country or area.
Yeah,
Okay,
maybe
so-
I'll just add a couple of sentences in the end. I mean, as Volker talked about, there is a range. So he said he done printings with 5 degrees or 35 degrees. And the fact is that both temperature and humidity, they obviously influence how the concrete is pouring out. So there's always some fine tuning. And I think what Vitauta said, that we work in close cooperation with our customers, and maybe that last fine tuning is always done on site, because that cannot be done beforehand. That can only be done once we know what is being printed and in what conditions it's being printed.
Okay, so you can send people from Cobot to the site in order to do fine tuning for the printing, depending on the material they are using and the condition they have there.
That's exactly correct.
Okay, great, thank you.
Any further questions?
Florindo, you have a question?
Hello, can you hear me?
Yes.
Yes.
Hello, good afternoon. I'm just curious about those building examples you showed. You showed some examples of 2 stories or even 3 stories, I think. What do you think that could be the big advantages of this 3D printing technique over the traditional construction processes for this type of buildings? I mean, what were, I mean, of course, we know the advantages of 3D printing, of course, and of course that it's a new technology with new challenges. But if you have to select some 1 or 2 advantages of this technique over the traditional ones, I mean, in the buyer perspective, what could be, in your opinion, the most advantages? I don't know if you have a simple answer for this, but that's if you can give some.
Vitauta, should you go or can I go?
Of course. Yeah, so in essence, as we mentioned, main things are speed, and maybe not customers that we have are not only, let's say, focusing on one side, but on the broader picture. So let's say at projects in essence, with the speed, how much, let's say, how much can they increase their construction capacity, let's say within a year, how much they need labor force for each of these sites, how much they can reduce. So they are mostly looking at these aspects in terms of using our 3D printing technology. But more than that, maybe as we mentioned, that a 3D construction printer is also a robot, and it does what you tell it to do, right? So it's also that there comes in new processes and new methods, let's say, of looking into how to print a building and incorporate more and more details and make it more automatic, whereas you can leave out spaces that you print, let's say for electrical conduits and so on, where let's say an electrician comes in and he doesn't need to, let's say, knock out some part of the wall to make installations or such. So basically, it helps to plan ahead with the idea that a robot will automatically prepare, let's say, the structure for you to then later on work in.
Yeah, I think I can
Thank you.
probably add a little bit more to that. So by traditional, probably you mean either bricklaying or maybe precast. Again, most of these would be, you don't have freedom of form. So you basically have a very restricted setting. So you cannot improve topology, meaning you cannot gain on material saving, and also you cannot have architectural, more, let's call it, different buildings. And another thing that I would say, I actually should have touched this point in my presentation, is that there's a lot of time saving in plumbing, electrician, all of that, because everything comes from the building information modeling to the printer. So all the holes that need to be made, they are made in advance. So they can just be all the electrical components, heating for the floors that can just be assembled, rather than having to drill walls or all of that. And there's also another point. Imagine that instead of printing one house one by one, you want to print, let's say, 50 straight. You can actually start preparing the foundations for the next one, and then you just move the printer. If it is on tracks, you can just print one. Okay, this is ready, move on to the next one. You don't need to be taking the printer apart, all of it apart, and then assembling on some other place onto the next one. Whilst if you had a traditional construction way, then you need to do something like that.
Okay, thank you.
Sorry, thank you very much. Do we have a last question, maybe? If not, thank you, Ricardo, for a very interesting presentation. So we can shift to the last speaker today. So it's Matteo Baldassari.
Here we go. Hi.
Okay, hello, Matteo.
Hi.
So, Matteo, you are the founder of Concrete. I don't really know.
Correct.
Okay.
Say correct.
Concrete. So you are specialized in building additive manufacturing system and materials. You are involved in both technical and business development aspects of the company, and mainly focus on the development of new applications and innovative materials for different markets. You have 10-year experience in digital manufacturing applied to construction and building industry. Before founding Concrete, you work on several engineering architecture firms and research center with a focus on digital and computational design. And you are graduated from the University of Architecture in Rome.
Correct.
So welcome.
Perfect. Thank you very much.
You're welcome.
Thanks. Can you see the screen correctly?
Yes.
Great. So concrete, yes, we are a company that started in 2016. This has been founded by me and my co-founder. And since the beginning, we started developing this technology for construction. So it's in a way related to what we have seen so far. So we have always been into this field of additive manufacturing and construction. And that's the reason why we founded the company. And it's a bit different from what we had seen so far. So there are a lot of similarities, but also different aspects. The process we use is basically different from extrusion technology. We use powder-based technology and binder jetting specifically. So one of the main focuses since the beginning was to basically do large-scale additive manufacturing. But
and then we have again okay. And then in the afternoon, we conclude with cement. Cement with three technologies based on extrusion. The last one based on powder bed. And I believe that they are complementary technologies. And in whole, we cover several aspects from hardware, robot, Cartesian technology, and other mixed technologies to software, control and computer-aided manufacturing, monitoring and closed-loop real-time technologies. Also, modeling and simulation, that is an important aspect, materials, that several case studies from engineering side to design, arts, and architecture. So I think it was a very interesting day, and this recording of the video, I think that could be helpful for the future to see again some details and aspects of these technologies. By the end, I could say that, but this is my opinion, that comparing to the other additive manufacturing technologies, like the medium size that came from the end of 80s, I think that we are still in the infancy of printing big. I think there are a lot of technologies, a lot of working that are being done, but I still, it's my feeling that we are still in the infancy. So there are a lot to explore, and I imagine in the next 5 years, we will see a lot of things implemented in industry, in the construction, arts, design, architecture. So, okay, it's my opinion. I think it's an overview that a lot of people also agree. And by the end, I need to acknowledge the organization, Olivier, that work all the day, Estia also, and all participants, mainly those that make the presentations, and now it's also important to see who will win the best presentation. I don't know if you want to say some words, Olivier.
For my part, it was a pleasure to be part of these conference dates. It was very interesting. Obviously, I know more about additive manufacturing for metal parts, but the presentation of Emilio Hanson plastics was very interesting, and the presentation for cement application too. So I also want to thank you for the invitation. It was very, very, very interesting, and to thanks Professor Mitchell also. Thank you. And maybe next year we are going to have a next event with also a lot of presentation.
Even larger 3D printing. next year to even larger. So thank you very much, Olivia and Artur, for drawing up the program and for chairing the session so successfully, and to thank all of the speakers. Obviously, only one of you will be a winner, but all of you have provided us with a great deal of knowledge, and you've all displayed a lot of enthusiasm. And so it's been a great day. Of course, we need to thank Philippe George and Renato Batista for the technical support of the day and the organization. And to remind you, if you've enjoyed today, this is a conference that runs throughout the year, in which there's a session like this on the first Thursday of every month. And as I showed at the beginning, but perhaps I will just show again, the next two sessions in August. You can, because it's virtual, you don't need to be here. You can just look on your phone on the beach. And the next session is about natural products and manufacturing. Of course, this part of the advantage of having a different theme each month is that the topics vary quite a bit. But in the 2nd of September, we have something which is probably closer to the hearts of people here today, which is on manufacturing and digital twins. In both of these, we already have some keynote speakers lined up, but we would welcome additional presentations for contributed, or if you have suggestions for keynote speakers, please send them to the email address on there. And we will close the voting at maybe at 6 o'clock, and so I will email the results to all of those here today. So thank you very much, and enjoy the summer.
Thank you.
Thank you very much.
All the best.
Yes.
Thank you.
Bye-bye.
Stay safe.
Yes.
Yeah, you too.
All right.